Okay, so picture this. You've got this room, right? And it's just piled high with like everything, clothes, books, you name it.
I can picture that, yeah.
And you need to find something, but it's like buried under a mountain of stuff. That's kind of like data fragmentation in MongoDB.
It really is. It's that feeling of, okay, I know it's in here somewhere, but how on earth do I get to it?
Exactly. So in this deep dive, we're going to tackle MongoDB fragmentation. We'll figure out what it is, why it's a pain, and how to deal with it. Whether you're a seasoned pro or just starting out, stick with us. You're going to learn some serious MongoDB magic today.
Absolutely. And, MongoDB is amazing for its flexibility. You can store pretty much anything in there, which is awesome. But as your data grows and changes, well, you inevitably end up with some gaps and inefficiencies.
Right, just like that messy room.
Yeah, exactly. And that's what we call fragmentation. It's like having these pockets of wasted space within your database.
So how bad can this fragmentation thing really get? Is it just a minor annoyance? Or can it actually bring your whole system to a grinding halt?
Well, it can be anything from a little sluggishness to, pretty serious performance problems. Think about it. If your data is scattered all over the place, your queries have to work a lot harder to find what they need.
Oh, I see. So it's like trying to find a specific book in a library where the books are just randomly placed on shelves.
That's a great analogy. And the more fragmented your database gets, the more noticeable those performance issues become. We're talking slower websites, delayed search results, the kind of stuff that can really frustrate users.
Nobody wants that. So how do we even know if we have a fragmentation problem in the first place? Are there any warning signs?
There are. Starting with MongoDB 5.0, you've got this handy command, db.stats 1024.1024.1024.free storage size. It basically tells you how much storage space is technically free, but unusable because of fragmentation.
So it's kind of like checking your MongoDB's vital signs, right? What should we be looking for in the results?
Right. The higher that free storage size number, the more fragmented your data is. And if you want to check for both data and index fragmentation, there's also db.stats 1024.1024.1024.total free storage size. Both are really useful.
Okay, so let's say we run these checks and, oh no, we've got a fragmentation problem. What do we do about it?
Well, you've got two main options, compaction and initial sync. Let's start with compaction. Think of it like reorganizing that messy room. You're basically rewriting data and indexes to make everything nice and compact and hopefully free up some disk space.
And I'm guessing compaction is especially important if I'm using the Wired Tiger storage engine, right?
Yeah, definitely. Wired Tiger relies on compaction to perform at its best. And here's a cool thing. From MongoDB 4.4 onward, you can actually run compaction on secondary nodes.
Oh, that's nice. So you don't have to interrupt your primary node, which is busy handling all the live traffic.
Exactly. It makes the whole process much less disruptive. And speaking of less disruptive, MongoDB 8.0 introduced a pretty neat feature called dry run.
I've heard of that. Tell me more about it.
Well, it's like a test run for compaction. You can basically see how much space you could reclaim before actually going through with the compaction process.
No more guessing games. I like that. But I've heard that in older versions of MongoDB, compaction used to be a bit of a pain, right? Like it would block everything while it was running.
That's true. It definitely used to be more of a heavyweight process. Before version 4.4, it would lock everything up. But starting with 4.4, they made some big improvements. Most operations can continue while compassion's running, although some things like dropping collections or creating indexes will still be blocked.
And then they made things even better in 6.0.2, right?
Yeah, in 6.0.2, secondary nodes can actually replicate and handle reads while compassion is going on. It's become much more efficient over time.
So it's not the scary monster it used to be.
Not at all.
Okay, so any other pro tips for minimizing downtime when we do have to run compassion?
Sure. A good strategy is to compact your secondary nodes first, then promote one of them to primary, and then compact the former primary. That way you keep things running smoothly throughout the whole process.
Clever. So that's compaction. But what if it's not enough? What if we've got like a truly epic case of fragmentation?
Well, for those extreme cases, there's initial sync. It's a bit more drastic. It's like completely clearing out that messy room and starting from scratch.
A clean slate. I like the sound of that. But, compaction kind of feels like sweeping the dust under the rug, right? You're just rearranging things, not really getting rid of the problem. So wouldn't initial sync be a better solution in most cases?
That's a good point. Compaction is great for routine maintenance and smaller issues, but if you've got really severe fragmentation, initial sync might be the only way to truly get rid of it.
Got it. So how does initial sync actually work? Walk me through it.
Okay, so you pick a secondary node that you want to sync. You stop the MongoDB service on that node, remove it from the replica set, and then restart the service. That triggers a full sync from the primary node, basically creating a fresh, defragmented copy of the data. Once it's done, you just check the replication lag to make sure everything's up to date.
Sounds pretty straightforward. But what if my primary node is the one that's super fragmented?
No problem. Just promote one of the secondary nodes to be the new primary, and then you can do the initial sync on the original primary node.
I get it. So we've got these two options, compaction and initial sync. How do I know which one's right for me? Give me a decision tree, if you will.
Okay, so if you're looking at, say, less than 20% fragmentation, and you can only afford a few minutes of downtime, compaction is probably the way to go. But if you're dealing with like 50% or more fragmentation, and you need to completely clean things up, then initial sync is the better choice, even though it takes a bit longer.
So it really comes down to how bad the fragmentation is, what your system needs are, and how much downtime you can handle.
Exactly. You got to choose the right tool for the job. And don't forget, the key is to be proactive. Don't wait until your database is completely overwhelmed by fragmentation before you do something about it.
Right. Regularly checking for fragmentation, knowing how to use these commands, and understanding when to use compaction versus initial sync. Those are the secrets to a healthy and happy MongoDB.
Couldn't have said it better myself. Now, here's a question for you. How often are you checking for fragmentation in your MongoDB setup?
Good question. It's definitely something to think about. And for everyone listening, remember, a little bit of preventative maintenance goes a long way. Keep that data nice and organized. Your MongoDB will thank you for it. All right, folks, that's it for today. Thanks for joining us for another deep dive.
Thanks for having me.
Until next time.
See you later.